In the last video, I promised that we would do lots more examples of these identity proofs, right? So let's do a few. Number one, cosecant theta times sine theta minus sine squared theta is equal to cos squared theta. Okay. What do we do? Well, I notice the left side looks a little bit more complex than the right, so I think I'm going to work on the left side. And one thing I want to do to start is write everything in terms of sines and coses, right? Just so I'm speaking the same language across the board. Cosecant, I don't like that. I'm going to change that. That's 1 over sine theta, right? Times sine theta minus sine squared theta. That's my left side. Well, 1 divided by sine theta times sine theta, those kind of cancel, right? And you're left with 1, right? 1 minus sine squared theta. Now, if you recall your Pythagorean identity, the Pythagorean identity says that cos squared theta plus sine squared theta is equal to 1, right? If you move the sine squared theta to the other side, it says that cos squared theta equals 1 minus sine squared theta. So this is your Pythagorean identity, and based on this, it says that 1 minus sine squared is equal to cos squared. So I can swap this out for cos squared theta, right? Cos squared theta. And now it's the same as my right side. So I have successfully proven that my left side is equal to my right side. That's the end of my proof. So these questions are kind of fun. They're all sort of like their own little puzzles that you have to work through. There's no one way to solve them. There's always multiple ways that you can go about them, right? But typically there's one way that's usually the quickest or easiest. Let's keep going. Let's do another example. Let's say I have 1 plus tan squared x times cos squared x is equal to 1. So again, the right-hand side's already pretty simple. Let's work on the left. So the left side equals, and what can we do? Well, first I'm going to change that tan squared. I'm going to make it sine squared x over cos squared x, right? I like everything written in terms of sine and cos, and it's multiplied by cos squared x. Okay. Next, I can distribute this cos squared x into the bracket. So 1 times cos squared x is cos squared x. Cos squared x times sine squared x over cos squared x. Those coses will cancel, and you'll just be left with plus sine squared x. And if you recall the Pythagorean identity, which we just talked about, cos squared plus sine squared is equal to 1. Hey, that's the same as my right side. My left side equals my right side. I'm happy. My proof is done. Okay, let's look at another example. Number 3. We have cosecant x plus cotangent x equals sine x divided by 1 minus cos x. Okay. What side do we want to work on? Let's start on the left side, because I can change this cosecant, right? I can turn that into 1 over sine x, and I can change that cotangent x. I can make that into cos x over sine x. I can add these together. 1 plus cos x divided by sine x. Now at this point, you might be thinking, okay, I'm kind of stuck. How do I make this look like this over here? Well, there's a couple things you can do. For one, you can recognize that the answer on the right has a 1 minus cos x on the bottom, right? We don't have that over here. So maybe we add 1, right? Maybe we multiply by something with 1 minus cos x on the bottom. And if you do it to the bottom, you have to do it to the top as well. So I'm going to add 1 on the top as well. And then we also notice that, well, there's no sine x on the bottom on the right side, but there is here. So maybe we have to cancel that out by putting 1 on the top. So I'll put sine x over sine x. Okay, that's enough for now. Let's try to deal with this and then see if we have to add anything more, right? So I'm always looking to the other side to see what I need and see if I have to add anything, right? Okay, so what do we get? Well, on the bottom, you have sine x times sine x, which is sine squared x, and then that's being multiplied by 1 minus cos x, so I'll leave that alone for now. On the top, you have a 1 plus cos x times 1 minus cos x. You can multiply those together, right? Do a FOIL. You'll get 1 times 1 is 1. 1 times negative cos x is negative cos x. Cos x times 1 is positive cos x. Those two terms will cancel. And then cos x times negative cos x is minus cos squared x, just like that. It's kind of like a difference of squares in reverse, right? We're going the other way. And then times sine x. Okay? What's going to happen here? Well, what's fun is that we know that 1 minus cos squared x, according to Pythagorean identity, if you write it out, that's going to equal sine squared x. You have a sine x here, so you can leave that. Sine squared x on the bottom as well. Those two terms are actually going to cancel out, which is really nice. And then you have a 1 minus cos x on the bottom. And that's really the right side, right? This is equal to just sine x over 1 minus cos x. That's what the right side initially looked like, right? Sine x over 1 minus cos x. So you're all done. So now you can say left side equals right side. That's the end of the proof. So with these identities, you really can do whatever you want. The only thing I would recommend not doing is taking something from one side and moving it to the other side, right? Either by multiplying or subtracting or anything like that. Try to keep everything on the side they're on and just work on one side at a time, right? You can work on both sides, like work on one side and then work on the other, but don't move things back and forth, okay? That's my one thing I would caution you about. Number 4, we'll have 1 minus cos y minus sine y squared equals 2 cos y sine y. Let's start with the left side. Not sure why, sometimes your intuition just tells you to pick one side over another. And again, you can work on either side and probably get your answer, but it looks like the left side has more potential for simplifying than the right. So what can we do? Well, I could expand this bracket, right, because it's squared. So what I really have is 1 minus cos y minus sine y times cos y minus sine y. And then you can FOIL that, right? So you'll have 1 minus cos y times cos y is cos squared y. Cos y times minus sine y is minus cos y sine y. You have that again. Same thing. Minus sine y times minus sine y is plus sine squared y. These two terms come together. So you get 1 minus cos squared y. Negative that is negative 2 that, but it's minus. So it's going to become plus 2 cos y sine y. And then minus sine squared y, just like that. Now, what ends up happening? Well, if you recall from your Pythagorean identity, cos squared y plus sine squared y is equal to 1. So if you have the opposite, if you have minus cos squared y minus sine squared y, that's equal to negative 1. So this term and this term together make negative 1, and negative 1 will cancel with this positive 1 on the front. You can think of it that way, or you could sub in this for 1 because it's equal to 1, and then they'll also cancel. Regardless of how you draw it up, this 1 is going to cancel with this minus cos squared and this minus sine squared. And all you're left with is 2 cos y sine y, which, if you look at the right-hand side, is exactly the same. So we have completed our proof. Our left side is equal to our right side, and that's it. Okay, let's do another one. Number 5. Let's say we have 1 plus sine y squared divided by cos squared y equals 1 plus sine y divided by 1 minus sine y. Okay, in this example, I think I'm going to work on the right side for now. They both have potential, right, to be simplified, so we might come back to the left side, but for now let's try the right. So on the right side, you have 1 plus sine y over 1 minus sine y. You recognize that on the top, you want there to be 1 plus sine y squared, and here there's just 1, right? So I could multiply that by itself, right, to get it squared. So I could say 1 plus sine y over 1 minus sine y. I could multiply that by 1 plus sine y to get the top to be 1 plus sine y squared, just like the left. And I have to do the same thing to the bottom, obviously. Can't just do it to the top, so you get that. So on the top, our numerator is basically done, right? We have 1 plus sine y squared, that's what we want. And on the bottom, if you multiply this out, 1 times 1 is 1, 1 times sine y is sine y, minus sine y times 1 is negative sine y, those are going to cancel, those middle two terms. And then minus sine y times sine y is minus sine squared y. Saying sine y is starting to sound a little bit funny because I keep saying it so much, but that's okay, let's keep going. From here, if you look at this, whenever you see a 1 in a sine squared or a cos squared, you should be thinking of that Pythagorean identity by this point, right? It comes up in almost every question. 1 minus sine squared, that's equal to cos squared, right? So what I have so far is 1 plus sine y squared over cos squared y. And that's actually equal to my left side. If you look at the left side over here, it's the exact same. So I could say, yeah, my left side is equal to my right side. I'm all done. That's my proof. Now, I've said before, there's multiple ways you can do these questions. An alternative to the way I just did it would be if you said, I want to work on the left side, right? And you said, okay, the left side is 1 plus sine y squared, or I can write it as 1 plus sine y times 1 plus sine y, just like that. And that's all over cos squared y, and we know cos squared y is equal to 1 minus sine squared y, thanks to the Pythagorean identity, right? And then you can factor the bottom. It's a difference of squares. So you'll have 1 plus sine y times 1 minus sine y, right? And on top you have 1 plus sine y times 1 plus sine y. And then some of those will cancel out. You'll be left with 1 plus sine y over 1 minus sine y. And that is what we had on the right side. Left side equals right side. So you actually have lots of options, right? You could work on either side and you could still get to the end of your proof. Okay, let's do a few more. Number 6, I have cosecant squared theta divided by cosecant squared theta minus 1 equals secant squared theta. So again, everything here, I'd like to turn it into sines and coses, so I'm going to do that before I even start, right? Secant squared theta is the same as 1 over sine squared theta. And then on the bottom you have 1 over sine squared theta minus 1. And that's equal to 1 over cos squared theta, right? That's really what we have here. And you might say, well, this just got a lot messier. This didn't really help. But let's take a look, right? Let's work on the left side, because the left side is pretty messy. So the left side, what you have is 1 over sine squared theta. I'm going to change the way this is written. Instead of writing it like a big fraction, I'm going to say 1 over sine squared theta divided by 1 over sine squared theta minus 1. And instead of putting minus 1, I can make a common denominator. I can say sine squared theta over sine squared theta, because that's equal to 1, right? It's like subtracting 1. And so now what do I have? Well, I have 1 over sine squared theta divided by 1 minus sine squared theta on top, divided by sine squared theta on the bottom, right? Well, 1 minus sine squared theta, that's just cos squared theta, right? So really what you have is this divided by cos squared theta over sine squared theta. And we all know that when you divide two fractions, we've talked about this before, you can change it to multiplication and flip the second fraction, right? So you have 1 over sine squared theta times sine squared theta over cos squared theta. Those sine squares will cancel, and you're left with 1 over cos squared theta. And isn't that what we had on the right up here after I changed it? That's what was on the right. So now I'm done, right? I can say left side equals right side. My proof is complete. Okay, let's do another one. Number 7, 2 cos squared x minus sine squared x plus 1 divided by cos x is equal to 3 cos x. So obviously the left side's a lot more complicated. I'm going to work on the left side. Okay, now what do I have? Well, I have 2 cos squared x minus sine squared x. If you see this 1 here, because I have a sine squared here, I'm kind of tempted to swap out that 1 for a cos squared x plus sine squared x, like the Pythagorean identity, right? Swap it out. And the reason I say that is because I think the sine squared I introduced will cancel with this sign, and then all my terms will have coses, and then maybe the coses will cancel. So I'm already thinking ahead, right? So let's try that. 2 cos squared x minus sine squared x plus, instead of 1, I'm going to put cos squared x plus sine squared x all over cos x. This sine x and this negative sine x, or sine squared x I should say, they'll cancel. On top you'll have 2 cos squared x plus cos squared x, that's 3 cos squared x divided by cos x. That cos x on the bottom will cancel with 1 on the top, and you're left with 3 cos x which is equal to your right side. Therefore, my proof is complete, and I'm happy. That's one way to do it, right? It's by no means the only way you could do it, right? You could split up this 2 cos squared x. You could say, what's 1 minus sine squared x? That's equal to cos squared x, right? Like, there's so many ways you can go about this, but they're all using the Pythagorean identity. They're all doing the same math. This way might not even be the easiest way. I think the easiest way would be to say, oh, this is equal to cos squared x, swap it out, and then just skip to the end, right? So, again, whatever way you're comfortable doing it, whatever patterns you see in the question, attack those. Don't necessarily do it the way I'm showing you. Do it however you're comfortable doing it, as long as you get the same thing on both sides at the end. Okay, last question. Number 8. Tan squared beta minus tan squared beta times sine squared beta is equal to sine squared beta. Let's work on the left side. It looks a lot more simple. Before I change the tans, because I do like to change tan to sine over cos, before I do that, it looks like I can factor out a tan squared, right? Because both these terms have a tan squared. If I do that, tan squared beta, factor it out, I'm left with a 1 minus sine squared beta, right? Now tan squared beta is sine squared beta over cos squared beta, and 1 minus sine squared beta is equal to cos squared beta, right? If you recall your Pythagorean identity. Those cancel, and you're left with sine squared beta, which is equal to the right side over here. Therefore, I'm done. That's my proof. So a lot of the time, these questions look intimidating, right? They look very complicated. It looks like it's going to take you a long time. But once you just do one or two things, right? Like simplify things to sine over cos, maybe factor something, maybe just move something around. Once you do one or two things, all of a sudden the threads start to unwind and the answer reveals itself, just like this. So take your time with these. Try not to get stressed out, right? Most of the time, they're a lot more simple than they look.